Hello everybody, how's it going? So this is my response to the seventh homework. I'm sorry because of the free Monday, my schedule kind of got I forgot which day it is, so it's a bit late. But I hope better later than never. So as for the homework, I think generally it was quite fine. Uh, well, let's get to it a bit. Let's take a look at let's take a look at the problems that have occurred. So um, yeah, in the homework. So for example, you were supposed to try the defensive programming. So the defensive programming means that you try to include in your code. You assume that whoever is going to be working with the code, working with your function, for example, using your function, they're gonna make a mistake, and I think that's a good presumption. I mean, people always try to put wrong things into the wrong plugs. I mean, since we're children, we are learning how to take. If you have a square, you're supposed to put it in a square hole. Some people just keep putting rectangles into the square holes. So, and it's pretty much the same thing with the defensive programming. So here, for example, you were supposed to create a function that calculates factorial. So indeed, there is a factorial function in Python. But so if I tell you a program such function, you're not supposed to use the one that is already pre-programmed. You should program it from the scratch using just the basic if, else, for loops and other basic stuff that we have introduced. So if you take a look at my solution here, it's not the only solution. I'm not saying it's the best solution either. So here, the typical thing is, I mean, we calculate a factorial, we know, or, well, let's say generally, we use factorial only for integers and for integers from 0 and positive integers. So we should check whether the given number is non-negative and whether it is an integer. Now here is a question: which assertion should go first, right? I mean, it's not a big issue, right? But at the same time, if you think about it, a program, it has a flow. It goes line to line, and let's say if there is a way that something is caught earlier, that's much better, right? I mean, it takes time to anyway to run through these lines. So let's say if these checks here, if these assertions they could be quite complicated generally. So it's good to put them in some logical order by the ones who are more likely to be failed before the others. So I would say that the first thing is good to find out whether it is an integer. So if the parameter, if the value that you got, if it's an integer, and then to check if it's non-negative. Some people, they did it the other way. I mean, it's not really bad. It's gonna work the same. But if you think about it, number that is an integer, that could be negative or positive. Number that is non-negative, that then could be integer. No, yeah, I guess here is not a really big. It's more of a question of a taste. All right. So then the way I did it here, I used the for loop. Another way, or typical way how you would program a factorial, is using recursion. I used here the for loop because we did not talk about recursion, but maybe let's take this moment to explain to people who don't know. So a recursion or recursive programming is when your function calls itself, right? So it can happen that the function calls itself before it actually finishes. So what happens is you go in the code, you get into the function, you run some part, and then the function calls itself with some new parameter. And so it opens another version of the function and it jumps into it. And again, and then maybe it goes inside. So it's kind of, it's something like the nesting, like if you had the nested intervals or nested lists. So the function keeps calling itself until it gets to some point where it finishes off, and then it slowly finishes off all the other functions. So let's take a look at the factorial right here. So we want to calculate factorial. So if the value is equal to 0, then return 1, right? Factorial of 0 is 1. Otherwise, return n times, that's our value, and call the function again with value n minus 1, right? So basically what you're telling this is, what's happening here is if n is 0, this is going to return 1, right? If n is 1, it's going to do 1 times and calls the functions itself with 1 minus 1 is 0. So it calls itself, it goes here with 0, that returns 1. That return, that will be the value here. So here you have 1 times 1. Now if n is 2, so cos n is 2, so that goes to else. So it's 2 times calculate factorial of 1. Factorial of 1 starts again. That's 1 times factorial of 0. And that goes here. Factorial of 0 is 1. So you go back and it's 1 times 2. Right? So in each step, and so you see here, so here you're creating that chain, right? Factorial is n times n minus 1 times n minus 2, n minus 3 up to 1. And that's exactly what you're doing here. In this way, you're building up this this product n times n minus 1. And in each step, you're building it by calling the function itself, and so on until it reaches this point when n is equal to 0, and that's the final one, and that just it returns 1. So I mean, logically this makes sense. This is quite useful. It has some possible disadvantage. The disadvantage here with this code or with the recursion is that the Python uses a lot of memory, right? Because it opens, so let's say here I say calculate factorial of 23, that works on both. Look, this is with the for loop, that's right away. This is with the recursion, that's fine. Now let's try something bigger, factorial of 1000 with the for loop. Oops. Overflow, result too large. Okay. Okay, that's my assertion. Alright, I'm gonna talk about that one just in a moment. I want to show something else. So you see, I get it here immediately. Here, let's put 1000. I had a result immediately. Now let's try 10,000, factorial of 10,000. That's a horrible number. See, we got it immediately. It's a whole page long number with lots of zeros. And now let's try it here. Let's try it here. And look, we are waiting, and now we got an error. So there is no problem with the program, but look at the error. It says recursion error, maximum recursion depth exceeded. So the problem is that if you do a factorial of 10,000, so Python has to do this cycle 10,000 times, right? It has to go n, 10,000, 9,990, and so on and so on. And in each time it recursively calls the function itself. So it puts a place in the memory where it has to put this function, and so on and so on. And that takes so much memory that 10,000 is too much, and that is what we call it. It exceeds the recursion depth. It's too deep. Right? We said that it's like nesting. You're going in and again 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 in. So that's one possible problem, is that when you use recursion, there is something like a recursion depth, and you cannot exceed the maximum recursion depth. So one has to be careful about that, but otherwise it's quite fine. So yeah, this code here is just the simplest one. This definitely is not a good example of defensive programming. I just put it here for quickly so we can see how it works. So here, let me go back to normal numbers. Here, I want to just show one more assertion. So in the beginning, I had the assertion that the input has to be integer and it has to be non-negative integer. All right. And then another thing is, before returning the factorial, I have here this assertion that uses this formula, that the factorial is larger than square root of 2 times pi to the power n, and so times n to the power n plus 1/2, Yeah. So this is called the Stirling's approximation. So for factorial, there exists something called Stirling's approximation. Find it out. Basically, it's just an estimate uh, how the factorial grows with respect to the power of n, right? And this is what we can use here, and I'm using using here to a certain extent to check that my formula here is right. Right, again, in this defensive programming, I mean, I can be checking for maybe the user is going to use the function wrong, it's going to give wrong data, it's going to give 1/2 or -5 or something. I don't want that. But also maybe my code here, maybe this does not produce the factorial n. Maybe I made a mistake here, right? Maybe instead of times I, maybe I put here plus I or something. So this does not produce a factorial, and how am I supposed to do? How do I know that? So that's why I put here this assertion where I use this Stirling's formula. So now this always checks that the factorial is larger than the lower estimate by Stirling's formula, and that gives another good kind of assertion. Yeah? It makes me assured. It assures me that my code is probably right. Okay. Looking more for the mistakes I've seen, yeah. So again, here it's the question of what should go first. Yeah, I guess here this is kind of whichever is fine. Here another example of code. So let's take a look at it. So if n is 0, then return 1. Yes, factorial of 0 is 1. Else, if n is greater or equal to 1, so that is okay, return n times n. So here the person used the recursion. Else, that is when n is less than 0, cannot calculate the factorial. Okay, so this is fine, except, right, for example, 1/2 will go through this, right? So here does not catch, this catches if whether the integer is negative or positive or 0, but not what if someone gives me a real number. So this would be a problem. And now let's get back again to this. So what happens, let's see here, right? So if I'm gonna turn off my assertions and I'm gonna run this, so my for loop when 1/2, I'm gonna get I'm gonna get an error here. Float object cannot be interpreted as an integer, and that's for the right. I mean, here is for the range function. So here anyway, I get an error in the range function. On the other hand, what do I get here? So if I did this here with the recursion, look, it calculates. It calculates like crazy, and again, it gets maximum recursion depth exceeded, right? So now what's the problem? How come this calculates? How come this does not give any error? And how come it exceeds the recursion error? Because the problem is that if you look at this code, right, whenever you call this function, it has only two options. Either n is 0 and then the function finishes, so it returns the value 1, or it just calls itself with a value n minus 1. So if you put 1/2, that does not go here, so it calls itself with -1/2, and that goes here, and that again does not qualify for this condition. And so this is going to keep just running the function, right, with 1/2, -1/2, -1 and 1/2, and so on. So that's also how you reach this recursion depth. That's another careful one thing that one has to be careful when they use the recursion, is that if you write the function, or if you give the function such value, or such if you feed it such input that never reaches this condition that the function itself actually could finish, right, it will just keep calling itself forever, and except that it reaches the recursion error, so the recursion depth. All right, so that's another question. Another thing one has to be more careful when you use the recursion is to really make sure that whatever the input of the function is, that either it reaches the condition when the function can actually finish, or there will be some assertion error, right? Okay, and this last one, if n is 0, then pass. Okay, else for I in, yeah, so here is for I in range. So here we do a for loop and you do assertion factorial n is equal to factorial n times I, and it says factorial n and factorial n times I does not have the same values. But so in that case, I mean, that's not what, so of course factorial n, well, it depends, right? For 0 and 1, the factorials, they have the same value, but factorial n and factorial, I guess, n times I. So that's one thing. If n is 0 and 1, then these things should be equal. Otherwise, they should not be equal, indeed. However, this assertion actually asserts that they have to be equal. This assertion is okay, it's gonna pass. The assertion is if they are equal. So if you wanted to have the assertion that they are not equal, then you should have put here. Then they should not have, here should not have been equal. Here we should have, for example, not this statement, okay? And anyway, I'm not sure why to run this in a for loop. So in this for loop, you're not calculating the factorial or anything. In this for loop, you simply just go and you test whether one number is equal to another multiplied by 1, 2, 3, 4 up to n plus 1. So when I is 1, it's going to be always fine. When n is larger, then it's never going to be fine. So, okay. So here, there's lots of trouble with this code. So please, whoever wrote this, take a look at this, think about it again. All right. So second exercise was for this test-driven development. So again, it's some sort of a concept. Some people use it, some people don't. Maybe sometimes it's useful, sometimes maybe it's not that necessary or not that useful. So again, the idea of this concept is that first you should think about the output. What is the expected output of your function? Based on that, you write some tests, you write the assertions, and then after that you start to actually program the function. So here we were supposed to do, right, a function that takes a list and returns a new list with unique elements of the original list. So only unique elements, right? So if I think about it, so what could you, again, this is not probably not a full, what can happen, right? So definitely one assertion I will have that the input has to be a list, right? The person has to give me a list. If they give me something else, that's a problem. Another assertion is that so when just before the function gives the output, right? So I'm given a list and I'm supposed to choose from it only the unique elements. So not the repetitive, the ones that repeat, the extra ones I throw away. So in the worst case, or in the best case, I don't know, somebody gives me a list of unique elements. So the function should output the same thing, right? Or if there is some repetitive guy, it should throw away the repetition. So my list is going to be actually shorter. So that's this condition here, which I would put just before the return statement, is to check that the list of unique elements is less, its length is less or equal than the original list. Definitely the list shouldn't grow, right? That means that there was some mistake in the code. So then, of course, what is always useful is, what if somebody gives me an empty list or 0 or something like this, kind of like a kind of a value, or that there is nothing. So yeah, that there is nothing. If the function needs to get, it needs to get some values and you give it nothing, what it should do. So this is what you should check for. Then afterwards, so how do I imagine the output? So of course there is it's not really so super clear, it's gonna depend, but let's say, so there is this first thing is, if somebody gives me a list of numbers which are all unique, then my function should give back exactly the same list, okay? Or if there is one element repeating, well, it should get rid of that element. or if there are only, so another, for if they are all the same elements, right, then it should give me a list of one single element. And then, for example, here I thought, how about this one? So if there are two repeating like this, so I mean there is lots of possible patterns. Here you could add, maybe you don't have to. So, but let's say I would say that if you've got like these, or at least some of these, they will probably, if your function works right, this will be right. Otherwise, it will not catch them. One thing, of course, here to be careful is the order, right? Depending how you write the function, I mean, it just says takes a list, put out a list of unique numbers. So I'm just putting them in the same order, but maybe you would want to have this one ordered in, I don't know, in a different way. So that thing has to be careful. That one has to be careful. All right, and so here all these assertions that go just after, or that are done to test the function, the output of the function. So I put them into another function, so I don't have to rewrite them all. I just write this test unique list. And then the other assertions I said, I put inside of the function. So first, whenever somebody gives me some input, I test that it's really, they give me a list. Maybe they didn't give me a list of numbers, but okay, I didn't want to bother myself with this here. Basically, okay, no, here was a list of not just number of unique elements. Yeah, I mean here actually, this function you could give it any kind of entries. I just tested it on numbers, but on actually not on just numbers, on integers. Okay, and here just before the end, before returning the result, I put here this assertion that the length of the result is less or equal to the length of the original list. Like I said, the list shouldn't grow, it should slim down or not change at all. All right, and the third part, well, that was the debugging. So that was to trying to find bugs in codes of someone else's. I mean, that's what happens to you all the time. You write a code, then you get an error, and then you're looking for it. What was the problem? So this is more here you were supposed to just run the code and practice finding out and fixing the errors. So anyway, so first I guess one would try to understand what the code does. So greeting is input. Hello pirate, what's the password? So we did not talk about it, but this function input that allows you to input, it takes your input from keyboard. Okay, and if there is a string, if you put here string, this is what is printed on the screen, and then you put your input. But I mean here we see this is supposed to be a string, but it starts with this, but it doesn't end with that. So definitely, yeah, that's one thing that we should fix. Okay. Okay, so let's run it. So now we get another call. Closing parenthesis, mismatch. So if greeting in so here, yeah, I mean what would make sense, I mean this is so here should be a list, right? Here on a list, so we want to put square brackets. So if greeting is in this list, though this list has just R, then it prints go away pirate, else if it prints greeting hater of pirates. Okay, so okay, invalid syntax, right? So if greeting in print, else if, because we need this again, right? And then like this, we need the indentation. Oh no. If I'm sorry, of course I want else here. Okay, and so now you see it gave me this input box, right? It wrote here, hello possible pirate, what's the password? And now, so this is what the input function. So if you don't know it, try to play with it a bit. This is great. It allows you to put the import from the keyboard. So I can put now, I put pirates should say ahoy and enter, and it says greetings hater of pirates, because it was not what's in this list here. So but if I'm gonna do R and run it. Go away, pirate. Okay. All right. And similarly with the rest of this, there were more mistakes and stuff. So yeah, so you can go through it again. So you can approach this in a very different ways. So this is a code that we did not write, so we don't know it. So first we should try to understand it. We should try to understand what the code does, or what the code is supposed to do, and then we can read it. Of course, some things are really easy to find out, right? I mean, here, look at this. Here the problem is that this kind of looks like you cut in the middle of the string. Well, if you want to use this guy in the string, then you have to use these here. The double ones and not the single ones. Okay, and now this gives me the now this is a string. Now no problem to have this, but you have to use a double quote, not a single quote, if you want to include a quote in a string. All right, so yeah, so you can so I would say for this debugging, first you should know what the code is supposed to do. Once you know that, I mean, of course, you can quickly browse through it to see, of course, sometimes changed parentheses or bracket or something like this. Well, those are, let's say, those are just a small mistakes. But yeah, but there might be some other some other issues, like here, right here we have elif, and then we have else here. So that's the problem. So anyway, so this was all for you, just more to practice on this. And anyway, this is something that you're going to be doing throughout the whole throughout all the programming you always do. All right, so that's all for today. Thank you.